Okay, in this video I want to talk about the transformation rotation. We're talking about clockwise rotation, and I put some things that you probably really need to kind of study. I mean, you really probably need to know this if you want to do well on the STAR test. All right, turning a figure 90 degrees, x and y coordinates. You really flip the x and y, and the x becomes negative. At 180, you just keep them both negative. If they're both positive, you just turn them both negative. If they're both negative, you make them both positive. And so 270 is flipped again, except this time it's the opposite of like 90 degrees. The first one you put a negative with, the second one, the x, you don't. And 360 is the easiest one because it's the exact same thing. Now I want to talk to you about rotation. I put a little square here. Hopefully it's a square. And so I put A in red. Now I want you to notice that your turning usually is the A's like the closest to the origin right here, and it will stay like that. So when we turn this shape, okay, and let's say that I turn it, and we're turning it around clockwise, okay, so counterclockwise would be going against the clock, okay, that's CC. Clockwise, counterclockwise, clockwise would be going this way. Alright, so I just want to kind of give you an idea that we're actually turning the shape this direction. So if I turn the shape 90 degrees, that means whatever is a flat line will now be a vertical line. Alright, so look at my line AB. My line AB, and we're going to use these points here to kind of help us. We're turning it 90 degrees. So we're going to say A is originally 2 and 5. Alright, now what's going to happen is we're going to flip this, and it's going to be 5 and negative 2. So I'm going to go to 5 and then negative 2. 1, 2, 3, 4, 5, negative 2, 1, 2. So this would be can't get my pen to write. It wants to play. Okay, so clockwise would be 5 and negative 2. So 1, 2, 3, 4, 5, negative 2, so it'd be right here. So this would be my new A. This would be my new A prime. That's that A. Alright, I'm trying to show you why A always stays closer. Alright, B would be, and I'm going to erase this, do it every time. Alright, so B, just enlarge an eraser so I can erase faster. Alright, so B, and I'm going to put it in a different color, black. Let's do blue, so that way it's a little darker, but it's not the red. Okay, so B is, we're going to go and say that's 1, 2, 3, 4, 5, 6, 7, 8. So it's 8, 5. So we're going to reverse. This is 8, 5, and we're going to reverse it, and it's going to be 5, negative 8. So 5. 1, 2, 3, 4, 5, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's right there. That'll be my B. Alright, C looks like it is 1, 2, 3, 4, 5, 6, 7, 8, but 10. So now this one is going to be 8 and then 10. And we're going to turn into this. 1, 2, 3, 4, 5, 6, 7, 8. It's actually looks like it's 1, 2, 3, 4, 5, 6, 7. Okay, 8. I just want to make sure I'm doing the right numbers. All right, so then it's reversed, and it's going to. And I kind of like wrote that kind of big. Let me rewrite this. Let me write this. So it's 8, 10. So it's going to be 10, negative 8. And so 10, negative 8, of course, a little further out. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 8, that's 5, 6, 7, 8. Alright? And I think you're kind of seeing what I'm talking about. And then D is going to be 2 and 10. And I'm showing this for a reason. 2 and 10, and then reverse would be 10, negative 2. And so if I do 10, negative 2, that means I go over 10, but I go down 2, and it's right there. And that's D prime. Okay, and so my point is like I was showing you this. If you see, I have turned it, and when I turned it, the shape actually turned. The A is still closer to the origin. No, every time I turn this thing, it's going to be, the A is going to always be closest to the origin. So whatever point's close to the origin, it will stay that way. No matter if we do 90, 180, or 270, the point will always, A will always be close to the origin. Okay, in the dilation part of this is that if you see the algebraic representation, we have x and y in an order pair, and then they show us that they're multiplying a half here. Well, I'm just giving an example, a half. It could be a whole number. I mean, like for example, I can come in here and I'm going to change this just so you can see it. They could come in here and say that this is a 3x and a 3y. See, so I'm going to change it back to a half because I haven't done one with a fraction yet. And so we're going to alright, so what we're going to do is just take 2 and we're going to multiply it to a half for x. See how x is being multiplied half? So my x values are here, my y values are here. So otherwise, half of 2 is 1, and then my other one would be 2.5. Half of 5 is 2.5. And then my half of 8 is 4, and then half is 2.5. And then half of 8 is 4, and half of 10 is 5. And that's 1 and 5. And so if I was to graph this, which I'm going to try to do real quick, we got 1 and 2.5. Alright, then 4 and 5, so this would be 1, 2, 3, 4, 5, so it'd go here, and then it'd go here, and it'd go here. And you can see that the shape, the red shape, is like half the size of the other one. Alright, and so it just shows you how it could work. 1, 2, 3, 4, 5. This one is 1, 2 and a half. Okay? So that's how you do the dilation. Okay, in this video here, we're doing a translation. You see the algebraic representation, and I have it saying that x plus 3 and y is negative 4. Translation means slide, so we're actually just going to take these points and we're going to add 3 to the x value and subtract 4, and the figure is going to slide, otherwise it's going to move. It still will stay the same size and same shape. So here we go. We're going to take the x value, which is 2, and the y value, which is 5. Alright, and I'm going to add, this is A, I'm going to add 2 to it, and I'm going to get 5 minus 4 is 1. So the order pair would be 5, 1. Alright, the B point. The B point is 1, 2, 3, 4, 5, 6, 7, 8, 8, and 5. And then when I add 3 to it, it's going to be 11 and 1. The C point is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 10. And so when I do it, it's going to be 11 and 6, because I got to subtract 4 from 10. And the D one is 2 and 10. And when I add 3 to the X value, that'll make it a 5. And when I subtract 4 from the 10, it'll be 6. So now I'm going to plot the A prime, which means I go over 3, 1, 2, 3, down 4. 1, 2, 3, 4. That'll be my A prime right there. Alright, my B will go over 3, 1, 2, 3, down 4, 1, 2, 3, 4, so that's right there. So that's B. My C will go over 1, 2, 3, down 4, 1, 2, 3, 4. This will be my C prime. And D is 1, 2, 3, 1, 2, 3, 4. That'll be my D prime, which is right here. And you can see that the shape just kind of moved down a little bit and to the right. It moved to the right and then down, just as it describes in the algebraic readiness.